Hello, everyone,
Hi.
and welcome to new Arduino EDUvision episode 8.
Wow, already 8.
Yes. Thank you for joining. Let us know where you're from. If you're educator, parent, student, use the chat on Facebook or YouTube.
Yeah, hello everyone and welcome. We had a lot of stuff today, so stay tuned.
Yes, and Halloween is coming, so we'll show more fun Halloween projects done with Arduino, some that we created ourselves and some from the social media that you shared with us.
Yeah. And we also have a special guest. We have Professor Chris Rogers from Tufts University, and he will talk about IoT in education, why it's important to integrate IoT in the curriculum. And also Chris has his house, like full of IoT things, a smart house. So he's going also to share with us what he has done with his house and also share other projects.
Yes. But before talking with Chris and talking about IoT, would you, Rox, like to share your Halloween project?
Yes, let's do that. Let me change my camera. All right. So this project is made with the Explore IoT kit. So basically, I'm going to explain you super fast how we did this. So we took an image here, and it's a bitmap image. So it's 240 to 240 pixels because it's the size of the display here. And then what we did is go to a website called Image2CC. And this was created by Jasper from the Netherlands. You can look him from in GitHub. So what you basically do, let me share my screen. Here, you upload the bitmap image, and then what this page is going to do is like it will transform the bitmap into a hexadecimal numbers with a code for the Arduino board. And then you can have also the code. So then we have it here on the display. And we make this with the Arduino IoT Cloud. So I can also trigger this with my phone, which I'm going to do this now. So if you listen to the music, and the skull is animated. So it's a simple project made with the IoT Explore that you can control with your phone, or you can go to the IoT website and you can control it also from there in the dashboard. So yeah, that's the Halloween project from my side from today.
Yes, thank you. And
Thank
if you
you.
didn't know yet, we have the new Explore IoT kit that is meant for beginners. So it starts from, you don't have to have any prior knowledge on IoT or programming that much. It's really simple, and you can do simple IoT projects with it.
Exactly. It's
Yes.
to get started with IoT.
Yes.
Nice.
And we can watch EDUspotlight, where Carl tells a bit more about the Explore IoT kit.
Yes.
The Explore IoT Kit is our latest educational product to be released. It focuses on learning Internet of Things and how to build exciting applications that can be remotely controlled and monitored. The kit revolves around three major things: the MKR IoT Carrier, the Arduino IoT Cloud, and the Explore IoT Platform. The MKR IoT Carrier comes with many different components, such as environmental sensor, capacitive buttons, but also a display. Since all the wiring is done internally, there's no need for a breadboard. In the Arduino IoT Cloud, we can use dashboards to control and monitor our devices. In the Explore IoT kit, we learn how to use the cloud and how to program the board. The Explore IoT platform has 10 exciting activities that guides you through the setup of the cloud, writing programs, and also how to apply them in a real context. Each activity also has a theoretical section that introduces many different exciting topics.
Thank you, Carl.
Yes.
So as we said, the Explore IoT Kit is a getting started kit designed to take the first steps into building internet-connected devices in a hands-on, easy way.
Yeah, exactly. So it comes with a carrier like this and the Maker 1010 board, and you can start learning about IoT in a hands-on, easy way. So it's really cool.
Yes. But I think next is something a bit more advanced.
Whoa.
And our special guest.
Let's bring him.
Yes.
So as we mentioned before, our guest is Chris Rogers. He's a professor of mechanical engineering at Tufts University in Boston. And with his students, they built IoT devices, drones, robots, among others. So let's bring Chris.
Hey,
Hello.
it worked.
Hello. Yes. Hello, Chris. How are you?
I am doing well, thanks. How about you guys?
Great. Thank you. So thank you so much for joining today.
So sure. If I can share my screen, I can show a couple slides of sort of my house and
Yes.
where we use it in education.
Nice.
So I wanted to start off with just, if you wanted to take one of these systems and just grab a temperature, how would you do that? So you can see this one is actually grabbing a temperature and a humidity. It's fairly simple. It's on the board. Once you have that temperature, though, how do you move it elsewhere? And so that's where we get into the dashboards, which you just demonstrated, where you can have a live dashboard that actually shows you the current value of the temperature. What's kind of nice is if you wanted to add the value of the humidity, say, we could link then that with the humidity, and this happens to be Wilma's humidity. So we can say, let's put the humidity up and connect that up, and then that will give you now a live value of the humidity as well as the temperature. And so in this way, you can connect up all your different devices. I tend to go a little bit nuts when it comes to my house. So the first step, right, is to program the endpoint so that it measures whatever you want, in this case, temperature and humidity. And then the second is to take your computer away and just have that thing always talk to the cloud. And then you can use your phone to query the cloud, like you just demonstrated, to see what the temperature and the humidity are in your house. You can also get a little bit more complicated. So I've got this one, which I'm assuming you guys can see because I can't see myself.
Yeah.
So this one actually will go out. You can see the light tells me it's going out and connecting up to my router. I just plugged it in, or just turned on the battery. It connects up to the router, gets an IP address. Very soon you'll see the IP address appearing there. So now we have an IP address. And then it'll go out and query my car. And it will say, how's the power in the car? And first it actually queries the time. So we now know the time. And then you can see that my car is fully charged. And you can see the temperature here and the temperature and also up at the house. So this is a modern version of a clock that tells you all the information you really wanted to know. You can also do a lot with images. So I have a system that takes a Raspberry Pi Zero. The Pi Zero has a camera mounted. Every minute, it pushes an image that the camera takes up to Dropbox. And then I have another server that just sits there, and every 5 minutes goes and grabs all the images that are on Dropbox and makes it into a movie. So you can see there, that was yesterday up at the cabin. In case you wanted to know, that was the Appalachian Trail, that ridge line there, which is a beautiful hike. So let's go up to my house. There's the house in the snow. And I gather all sorts of data, the alarm system, the geothermal, whether the water's flowing, thermostats. So there's a solar system up there that powers everything, vacuum cleaners, how much electricity we're using, and then a bunch of different cameras, and of course, doors. And I gather those all up, and that throws it all into a web page so that I can actually look at the data. I can see, I can zoom in and see what the alarm system was saying at different times. I can see what today looks like up at the cabin, and I can see a map of where the car is driven. So it can accumulate all these data. You can notice a couple things are not working. That's fairly typical in the world of IoT, that something breaks, and then you've got to go up and try and figure out what went wrong, which I spent a lot of time doing. So that's listening. You can also tell. So I can unlock the doors. I can turn on and off plugs. I can turn on and off lights, open the garage door, and then we have an air filtration system that I can mess with. So you can see I have a few apps on the phone to do all that. The one app there are two apps I wanted to highlight. IFTTT is if this, then that. It's a very easy way to get started. So what you do is you can write a code that'll push stuff up to IFTTT or grab stuff down from it. And then they've got it connecting to just 1,000 different interfaces. So your garage door or your lights or any of these other things. If you want to go that route, that's much easier. I tended to try and hack it all myself, which doesn't have nearly as much high success rate. The other one that I'd highly recommend is the upper left, which is the Orbi button. So almost all routers now have the ability to control them remotely. And so that's an app that lets me go into my router and make sure that the router is still working. I can test the rates. I can disconnect and reconnect different Wi-Fi endpoints. So it's a very useful thing if you're doing IoT from afar.
Nice.
So how does my house actually work? You can see it's got a ton of different processors doing a ton of different things. This is sort of the way I learned how all these different processors work. So we have Raspberry Pis that are sitting there pushing the alarm system or the heating system up to the Dropbox or the images. We have a central server that's messing with all those data to build up that web page that you saw. That the car is pushing to its own cloud. Arduino is pushing to its own cloud. The power system pushes to its own cloud. All these different things. The particle that does the geo, that's another microprocessor, pushes to its own cloud. You can talk to all of these clouds through REST API, so that's a fairly standard protocol. Almost all of them have an open protocol that you can mess with, and so my central server will query all those and then push up the data directly to Dropbox, and my phone at any time can read all that information off of Dropbox, assuming that nothing is broken, which is actually a fairly major assumption. So it's neat, it's fun, it wastes a lot of my time, but the question is, why should it be in school? And I think it should be in school for a couple different reasons. One is just so that kids are aware of all of this stuff going on. You're carrying an IoT device in your back pocket every day. The phone is continually giving information back to central. It could be your location, it could be your speed, it could be your heart rate, it could be your EEG. There's all sorts of things that nowadays it'll gather. And so there's this question of security. With whom should you share it? And how often should you share it? And starting to figure out the ethics around the sharing as well. So these are all major things that I feel very strongly kids should be thinking about and grappling with as they sign up for these new apps, because not many people actually read all the legal documents that comes with the app. So we can combine all of this for fun. So if you whip out your phone and you can have some fun. If I move my camera a little bit, hopefully you can now see my skeleton.
Yes.
Yes.
Okay, good. So we can use the phone to actually make the skeleton move. I don't know if you can see it moving.
Yes.
Yeah.
Or if you want to have fun with exactly the same phone, you can actually turn on and off the lights in the skull behind Melissa. Maybe.
Dun, dun,
And we can turn them off too. So anyway, that's the quick overview of everything. And lastly, I just wanted to end with a view out of the window of the cabin. Definitely my favorite part of the cabin. And thank you all for listening. And I'm happy to answer any questions that have come up on the chat.
Yes. So if there's any questions for Chris, please use the YouTube or Facebook chat. And I think there are a few already.
Yeah.
If you can see them. So there's
The one from.
what about latency?
I cannot see them. So if you guys can just read them to me, I'll just answer them.
Okay. There's a question. What about latency?
So latency, if you want to be controlling the skeleton, is an issue. If you're just worried about whether or not your heating system is working, then there's not much of a problem. So places where you don't have to worry about latency, like sensors and so on, you just use the standard Wi-Fi. If latency is important, like opening the garage door, you can also use local mesh networks with Bluetooth or BLE or Z-Wave, etc. And then have a central server.
Nice.
My question for you is that when you're not home, are you only staring the website and looking at what happens at your home?
The home actually emails me every morning the link to the website. Actually embeds the website in the email and then links to it if I want to zoom in on the data. So I just every morning I just check it as I check my email to make sure that everything is working. And so far it hasn't really detected any issues. Mostly it shows me that one of my sensors is dead and I got to go fix it.
All right.
Have you noticed anything new from your home when we started to add IoT or started to monitor your home in different ways? Have you learned something that you didn't know before?
I've learned a lot about sensors and sensor control and REST API and Wi-Fi going down.
Yeah.
And when I first started doing this, everything was open. Everybody had an API that you could control. Now security is becoming bigger and bigger, and so fewer and fewer things actually let me in and let me mess with it.
Yeah.
Yeah.
There's a
Another
question. What
question.
app did you use for full home display?
So I have a bunch of them on there. I wrote my own, which is just through a website to have it the structure I like the best. Other ones that I've used a bit are the straight out Apple Home is not bad, but it doesn't give me data and graphs. MATLAB has ThinkSpeak, which is a very nice graphical interface that I've used. Adafruit has a very easy feed system and graphs. The Arduino one now has graphs built in, which is really nice. But it's hard to implement then live video and the graphs. And yeah, that's about it.
Yeah.
I think we have another question. Which cloud we should use for the IoT? I want to make a project with ESP8266, as well as I want to send images as data.
So there are a number of cloud sites that you can go. There's Blink and a bunch of others that you can actually pay for, and then you can configure a nice dashboard. System Link, ThingWorks, all of those have a lot of capability, but they also have fairly high learning curves. I have found the easiest is to get a very simple IoT system working, but then write your own web page that configures it the way you want, because then it's easy to, with HTML5, it's easy to include video right next to plots. And there's a number of nice little free plotting packages out there, JavaScript plotting packages that you can import.
Nice.
Yeah. Thank you, Chris. For everyone who wants to know more about your work, we have on our remote learning site, arduino.cc/remote learning article from you or interview. And then Think Like an Engineer, Invaluable Insights from Professor Chris Rogers. So everyone, you can visit our remote learning site and check the article. And of course, if they want to contact you, what should they use?
Just crogers@tufts.edu.
Yes.
Yeah.
Great. Well,
thank you.
Thanks a lot. Have a good Halloween.
Yeah,
Thank you so much for your time.
Bye.
Bye. Yeah, so some people are asking about how to start with IoT. So of course we recommend the Arduino Explore IoT kit to get started with the IoT.
Yes, so you can find more from our store, for example, about the Explore IoT kit, and it's you can get started with learning about IoT, learning about, for example, how to secure how to create your own home security with the motion sensor, and these kind of to get started with IoT, and then you can after that you can go to more advanced projects or tools.
Yeah, and also someone is asking about the battery. In the case of the Explore IoT kit, we use a LiPo battery. So we have tested this, and this you can communicate the carrier with the cloud using the battery for a whole day. So it lasts like 24 hours. So it's nice.
Yes. And
Perfect.
then I would say that good news for everyone if you want to get started building some IoT projects, or if you want to build your own Halloween projects, we have a discount code for you.
Yes.
So inspired from today's theme, if you use the word pumpkin with all capital letters, you will get 20% discount on the Arduino Maker 1010 board.
Nice. So it's like this.
Yes.
It's really cool to get started with using the Internet of Things with the MKR IoT.
Yeah,
Nice.
and you can use the Arduino IoT cloud with this board, for example, and the cloud itself,
Exactly.
it's free to use.
Yeah, you can start experimenting with the IoT cloud and with the board. So it's really cool.
Yes, and actually we
Awesome.
have some projects that we created with using the board, but the Halloween projects. But before that, should we check one of the videos that we have,
Yes,
Halloween
let's
projects
do
from
that.
you guys?
Awesome. Which one? We start with which one?
Should we take the
Interactive.
So that was the trick that I created with my skull. So I have a skull. Actually, I have it here in the background. Oh, there. So I created a skull that whenever it detects light, it starts screaming and puts on the the LED lights that it has. And now I've taken off, so we don't all have to hear the pizza screaming. But if you put it, for example, in your wardrobe or in a closet, so when a person opens it and there's a light, it's gonna start screaming, and hopefully someone gets scared. This is a simple one that you can do with the Uno board, or you can do it with the Maker board, for example.
Cool. So it's like the skull trick. Nice. So let's check another one. This is called Interactive LED Pumpkin, and it was built by Therese, one of our colleagues, using the starter kit. So let's take a look.
So this one changes the color. The LED starts blinking when you open it.
Yeah, it's really nice. So with the starter kit, if you are aware or familiar with the starter kit, you can do something similar. So it's really simple. Nice. What else we have? Cool. So this project has a PIR sensor, and the jaw moves with a servo and controlled with an Arduino Nano Every. So let's take a look at the next one. It's called Arduiji, which is
the Arduiji is a robotic Ouija board connected to a homemade XY table and is controlled via an Arduino microcontroller. For the XY table, I started with 2 of the Actobotics camera slider kits. I used an 18-inch channel and a 12-inch channel to keep the form factor as small as possible. Luckily, I was able to use the same wooden platform I had made for the previous version to hold everything in place. The end of the Y-axis is not supported by the X-axis on one side. Instead, it has a ball caster on the underside to allow the Y arm to glide freely while putting as little strain on the X arm as possible. This allowed me to only use 2 motors and 2 pulleys. The DC motors that come with the camera slider kit were swapped out for stepper motors held on with a NEMA 17 stepper motor mount. The X-axis uses a 68-ounce motor, and the Y uses the small classic stepper motor from SparkFun. For the Ouija planchette, I used the same magnets that were used in version 1 and attached it to the Y-axis carriage. To drive the motors, I upgraded from the Easy Driver to the Big Easy Driver, which is capable of delivering more current per phase but is just as simple to use. To provide enough power for the motors, I'm using a 24-volt switching power supply, similar to what you'd find powering a 3D printer. For the firmware, the first step was to figure out each axis direction and orientation. Second, I needed to create a homing function that would move the carriage to a 0-0 position so I could begin mapping characters. I used my keyboard to jog the planchette in small increments across the Ouija board while each location was printed. From there, it was just a matter of recording each letter's coordinates, putting them in a lookup table, and having the Arduino move the planchette to that location.
Ooh!
Halloween spirit has come.
These teeth were too big for me.
Yeah.
We have a few more
Nice.
projects left.
Yes. Let's take a look. The next is the LED board. Let's take a look.
Cool.
Nice.
That's a
So
bit
if
spooky.
you are in danger, you can build this and ask for help.
Yeah. Modern way to.
Yeah, remember that these projects, that we're going to share the list of the projects so you can take a look at all the videos and see how you can build this. So then we have an animatronic pumpkin. Let's take a look at that video.
That was like a pumpkin Mona Lisa, following wherever you go.
A little creepy, but it's really nice.
Yes.
So you can also build yours and share with us. You can use our Facebook channel or Instagram channel and share your project with us. That would be really cool.
Yes. Yes, there's still time to share your project using the hashtag Arduino Halloween or just tagging Arduino. We would like to share your projects in Facebook and Instagram, for example. And then, of course, you can share here using the chat if you have some nice projects. And there was actually a question that what sensors do you use? But I'm not sure if that was for the skull that I made, for example. There I used the phototransistor to detect the light, the amount of light that it has. So if it's in the closet, then I put it like when it's lower than 50, for example. No, that's the one when I do the doorbell. So you can do it both ways. So you can have it in the closet. So when it's dark, it's not doing anything. And when you open the closet, it sees the light and it gets triggered and starts screaming. Or then you can do it the other way around. So when there's light, it's silent. But then when someone is in front of it, like a doorbell or in front of your door at home, someone comes there and covers the phototransistor and it starts screaming, for example. So there's two ways to use it. But for that, I use the phototransistor. Yeah.
But we also just post on the chat the full link of the video so you can take a look at the whole video and how they did it. So take a look at that. For the whole the videos that we show, you can go there and check the complete video. Nice.
Thank you.
Awesome. So I think that's it for the videos, right?
Yes. So remember, if you use the code PUMPKIN, the discount code PUMPKIN, you get 20% off from your Maker 1010 board, and you can start building your Halloween projects, maybe getting ready for Christmas projects, and use the Arduino IoT Cloud with the board.
Yeah, to control your Christmas trees or the lights on your house. It would be really nice if you really could build something and then share that with us.
Yes. And you can get started with your Christmas projects and share those then. Ready to share them. Yes. And if you're interested in the Explore IoT kit and you want to get it, you can find it from our store, or you can find your local distributor.
Mm-hmm.
Yeah.
Yes.
So you can find the list from remote learning site or from our store and purchase it that way.
Yeah, everything is there. And I
Thank
think
you for everyone.
that's it.
Thank you. There were a lot of good questions this time.
Thank
a lot
you
of
so
nice
much.
comments. And see you next week. It's our last episode for the season.
Ah,
So remember
oh.
to join. We have some special news.
For sure. Don't remember. Please remember to tune next Thursday at 5.
Have a happy Halloween.
See you.
Bye.